Welcome to Calc Chapter 28. Today we're going to be talking about the limit comparison test. Just from its name, we can kind of tell that this is similar to the direct comparison test, but instead of directly comparing two series, we're actually going to be looking at the comparison of their limits. So this is kind of the long drawn out statement. Suppose we have a sub n greater than 0 and b sub n greater than 0 for all little n greater than or equal to big N, where n is a positive integer. So basically just defining our bounds. There's three scenarios, first of all. Before we get into those scenarios, I do want to mention, when we are talking about these series, a sub n is our original series and b sub n is our chosen slash our new. So we are given a sub n, and then we have to choose a series to compare it to, and that is our b sub n. So our first scenario is if the limit as n approaches infinity of a sub n over b sub n equals c, and c is some number between 0 and infinity, then both the series converge or diverge. And this test is important because in this first scenario, it tests for convergence and divergence. So as long as they equal some number c, they both converge or they both diverge, depending on what this b sub n is doing. So if b sub n diverges, a sub n diverges. If b sub n converges, a sub n converges. 2 and 3 are a little different. So 2 says that if the limit as n approaches infinity of a sub n over b sub n equals 0 and bn converges, then an converges as well. So 2 only tests for convergence. If bn diverges and we get the limit is 0, then we can't determine it. We have to use a different test. And then same with the third one, same idea. If the limit as n approaches infinity of a sub n over b sub n is infinity, and our chosen series b sub n diverges, then an diverges as well. So 2 only tests for convergence, b only tests for divergence. So here's our first example, 1 over 2 to the n minus 1. And so looking at this series, we see that this is really, really close to the series 1 over 2 to the n power. And this is a geometric series, and we know that this converges because our r is less than 1. We can rewrite this as 1/2 to the n. So we know that series converges, and so we're going to take the limit as n approaches infinity of a sub n over b sub n. And remember, our a is our original, and our b is our new. And so we're going to take 1 over 2n minus 1 times, and then this is also kind of with the ratio test, we just flip the second fraction. So this is 1 over, or 2n over 1. So when we simplify, we just get 2 to the n over 2 to the n minus 1. And then looking at this limit, I know that as n approaches positive infinity, the 1 is going to matter less and less, and it's really just going to boil down to these two. So as it approaches infinity, this just ends up approaching 1, because 2n divided by 2n gives us 1, and so our limit is equal to 1. Since our limit is equal to 1, and it is in between 0 and infinity, and our chosen series converges, we know that the series n equals 1 to infinity, 1 over 2n minus 1 converges. So there's a lot of conditions for this test, but it's really not too hard once you get in the hang of dividing. So here's our DIY problem. We're just going to jump right into this. So I'm going to pause it in a second. If you want to pause it now and try it completely on your own, you can go ahead and do that. Otherwise, I'm going to kind of lead you guys a little bit and give you kind of a series to compare it to. So a good series to compare this DIY one to would be, I'd say, the square root of n over n squared. Again, just looking at that higher power on top and bottom. And then that we know is n to the 1/2 divided by n squared, and so this ends up being 1 over n to the 3/2. So this is a good series that I would compare to. So I'm going to pause now, write down the answers, and you should too, and make sure you're noting anywhere where you're getting tripped up or any questions that you have. All right, so here is my work for the DIY problem. You should have gotten that the limit was equal to 1, and so that this series also converges, since our original converges. So here are the ABC problems. Again, please try these out before you come to class. If you look at C and you think I can do it, you can go ahead and go straight to C. You don't have to start at A. But if you're maybe thinking I'm not really feeling confident, try A first to see how far you can get. And so these are the problems that I'd like you to try. In just a second, I'm going to shift over to the solutions. So these are the solutions for A, B, and C. So please make sure that you have A, B, and C done. Come to class with any questions that you have. Write them down, make a note of them, and also please make sure to like and subscribe. And thank you for watching.